Okay, so I wanted to make a video kind of comparing disk versus washer method, but I want to attack this from a very specific question I got about being confused about when do you use subtraction to find the radius. So I want to attack that specific idea. So what we're going to do is I've got this region, y equals 4x, x equals 0, y equals 4. We're going to revolve it these three different ways, but I want to really give attention to the radius for each of these. Okay, so of course I have this region, so the first thing that I need to do is I need to actually sketch this out. So here's my line, y equals 4x. You know, it's just something good enough. There are my lines, y equals 4 and, oops, this should say x equals 0. And okay, so this is the region that I'm interested in. And then the other just good practice to get into is, so I want to just note what those points of intersection are because that'll help me set up the integral. So now let's go ahead and do this. So I'm going to revolve this now about the x-axis. Okay, so in setting this up, so anything can happen when you revolve. So you won't know until you revolve if you're using the disk or washer method. Now in this case, now my center has gotten all like kind of wonky, right? So it's not a solid, it's got this funky center. So this will be a washer method. So this is going to be outer and inner radius calculations that we need to do. But here's the deal. It actually doesn't matter which method that I'm using. I'm really always thinking of using subtraction with my outer versus inner radius, even in this situation here. So you may have at first looked at this and thought, oh, but no, but this situation is really simple. There's no subtraction. There 100% is. Okay, so we actually just kind of get to ignore it for free because it's simple. So for my outer radius, remember, you use the object where you rotated. So from here to here, so here is what's going to comprise my outer radius. So I can see that for my outer radius, so this line here, remember, was y equals 4. So the outermost part is 4, but here's the deal. So a lot of times we just write 4 because it's like, oh, well, we're going to the x-axis. We are actually doing a subtraction here. We're doing 4 minus 0. So a lot of times when we think about revolving about the x and y axis, it's like, oh, but those are easy because I don't have to worry about like adjusting. This is why you are actually doing subtraction. It's just not needed, right? So we usually would just write 4. So when I come up with what my inner radius should be, so that's going from here to here. So the top part of that is going to be 4x and the bottom part is going to be 0. So there's everything that goes into this. And so now when I set up my integrals, this goes from 0 to 1. Because remember I set up these points, so I just look at the x coordinates, so it goes from 0 to 1. So my calculation will be 4 squared minus 4x squared. And so then I'm going to get 16 minus 16x squared. So this is what I'm going to integrate. So I will have 16x minus 16 over 3x cubed. And see, I'm kind of running out of space here. Sorry, from 0 to 1. So this will give me 32 pi over 3. Okay. So the whole point though, right, is that I actually really did use subtraction here. It's just, you know, it was kind of buried in. So now let's compare that process to revolving about the y-axis. So I can see when I revolve about the y-axis, so I get a shape that looks like this. So this looks like disk method. It is disk method, of course. So a lot of times when we think disk method, it's like, oh, well, I don't have to subtract anything. So again, you are actually doing a hidden subtraction here. So this is the shape that I'm starting with. So in this case, I start with highest minus lowest, right? So my radius goes from here to here because my center is right through here. So here's where my radius calculation is happening. So we do need to adjust this, of course, because now we're going about the y-axis. So the one adjustment that I want to make, so I've got this y equals 4x, so I can solve this into x equals 1 over 4y. Okay, so we're going to really go from this curve to here. So my radius in this case is 1 over 4y minus 0. So you probably, when you set up the integral, you don't write that out, right? Because it's like, oh, we're just rotating about the y-axis, or revolving. But the reality is, like, there is actually this hidden subtraction in there. So I've got pi 1/4 y squared dy. So this is going to end up being, what is this? 1/16 y squared. So ultimately I get pi times 1/48 y cubed. And so this needs to be evaluated from 0 to 4. So that will equal 4 pi over 3. Okay, so let's change it up. So we're going to have a slightly different question, and I want to rotate about y equals 4. So again, we want to, of course, draw our little picture. And there's my line now, y equals 4. So that's what I'm rotating about. So I have something that looks like this. So in your head, you're like, oh, this is disk method. But like also, okay, sure, it's a disk method. So yeah, it has a singular radius. But okay, so this shape here, this is what's generating everything. So when I'm doing my calculations now for this radius, this part here is the top of my radius and down here is the bottom. So when I'm computing my radius, I'm going from here to here. Hopefully you can see that. So I'm taking top minus bottom. So the top part of this is the line 4. And now the bottom part of this radius changes as we move along this line here. So that's minus 4x. So like I said, in my head, we are always doing a subtraction. It's just a lot of times it's like pointless to set it up. So when I set up this particular calculation, so this will be 4 minus 4x squared dx. And so that will come out to 16 minus 32x plus 16x squared dx. So that's what I need to integrate. So I'll make some space for that. So this will come out to 16x minus, let's see, 16x squared plus 16 over 3x cubed, and that goes from 0 to 1. So this will actually come out to 16 pi over 3. Okay, so hopefully that kind of helps a little bit. If not, feel free to leave a comment with some more questions kind of on this topic, but I think a lot of times people get confused with the subtraction, so I wanted to try to attack that particular idea. So if there's any other questions you have, you can just drop them in the comments. Otherwise, I will talk to you guys next time. Bye!